Hi everyone, welcome to today's YouTube video on calculating the potential energy of disassembling a hydrogen atom. The question reads, calculate the potential energy required to dismantle a hydrogen atom. Assume that the proton and electron are initially separated by a distance equal to the average hydrogen radius at ground state before ending up at infinite positions. So to solve this, we know that the energy is equal to potential energy plus kinetic energy, but we are looking for the potential energy U. So the potential energy U is given as 1 over 4 pi epsilon naught, 1 over 4 pi epsilon naught Q, that is E for the proton, and minus E for the electron, all over distance separating them, as the potential energy. So this is the hydrogen atom, this is the electron revolving about the nucleus, positively charged nucleus. So with this, we can easily see that of course we know that E is equal to 1.6 times 10 raised to power minus 19 coulomb. That's the charge. So it now means that U is equal to, this whole thing is approximately 8.99 times 10 raised to power 9. Then times, this is squared, minus 1.6 times 10 raised to power minus 19 squared, all over R is 0.529 times 10 raised to power minus 10 meters. So if we multiply out these things, this will give us times 10 raised to power. So we'll have minus 8.99 times 10 raised to power 9 times 1.6 squared, 1.6 squared times 10 raised to power minus 38 minus 10 all over 0.529. So you will see that we get it approximately equal to 27.2 electron volts. Remember, 1 electron volt is equal to 1.6 times 10 raised to power minus 13 joule. So that is how to solve this type of problem. Thanks and have a nice day. Subscribe and please like the video.